Thank you for taking the time to join us today. Before we get started, please feel free to use the questions tab through the presentation and we will answer at the end, time permitting. The presentation is being recorded and will be available via email on the call to everyone on the call by the end of the day. Lastly, there's a quick survey at the end and we would encourage everyone to complete and let us know how we did today. So go ahead and let's get started. As vaccinations become more available and more individuals become vaccinated, the topic on everyone's mind is when we can get back to normal and what does normal even look like. The main focus of today's presentation is returning to work as more employers seek to resume operations in the office. We've narrowed it down to 3 keys that we will be touching on. And we're joined by both Atmos Air and Aeroseal to dive further into 2 very important aspects of a safe return. Today's speakers are Brian Levine, VP of Sales and Marketing at Atmos Air, Art Wagner, Commercial Account Executive at Aeroseal, and I'm April Fakes, Director of Commercial Sales at Aeroseal. First, we're going to talk about COVID-19 and the HVAC system. The most important thing is the airflow and the ventilation. So 3 keys to a safe return. The first thing is source control, the second is ventilation, and the third is air cleaning. So let's talk about the implications of exhaust duct leakage. In garages, exhaust systems should be kept running before and after occupancy. And so that means that you're bringing in fresh air inside all the exhaust in garages to make sure that all that stale air isn't staying stagnant and potentially contaminated air is staying in parking garages. The CDC is also telling us that in hospital isolation rooms, there are 2 unique risks due to patients who have COVID. And so sealing and cleaning your ducts will ensure the proper use of exhaust fans to that criteria. And the third is in bathrooms, there's special risks due to toilets where flushing creates plumes of droplets and droplet residue. So we're going to talk a little bit about all 3 of those things and why it's important to have dilution in all of your spaces and why it's important that your exhaust fans work properly and that you're exhausting the air as designed. So small leaks are a big problem. 75% of ducts leak up to 30%. There's been studies done that show that it's the top building fault in all the buildings in the United States, up to $2.9 billion annually. And so sealing ducts not only save energy, but it increases your indoor air quality, which is our focus today, but also improves comfort. So we can not only save your occupants from being potentially contaminated by air, but we can also save energy while doing so. So there's been multiple studies done that show that air ducts leak. One in Florida, one in California came up with the same studies that light commercial duct work is especially leaky. This is really important for us as we talk about people going back to work, because that's, most of the office spaces are light commercial buildings, and that's what they're going to be going back to, the leakiest buildings. ASHRAE tells us that 75% of ducts leak up to 25%. There was even a study done at the Berkeley National Lab that told us that even newly installed systems typically leak up to 30%. So this isn't a problem that is just for older systems. It's not a problem in certain areas of the country. This is widespread that we see everywhere. So this is the study that I was quoting earlier. The Building Commissioning Agency, duct leakage is $2.9 billion a year. So not only is this a problem that we need to make sure that we take care of to make buildings healthier for our occupants to come back, but it is something that we could help save money with as well. So again, why do we seal ducts? We seal ducts for energy conservation, but right now what our most important focus is to improve indoor air quality. So we need to make sure that any airborne contaminants are not making it through the building, that they're all being exhausted out as properly designed, and that we're bringing in fresh air as the CDC and ASHRAE is recommended to dilute any contaminants in the occupied spaces. Sealing ducts also improves comfort. A lot of times when you're looking at remodeling projects and things like that, you can seal up ducts instead of replacing them. So there's a lot of benefits from sealing up the ductwork. So like I said before, the CDC has issued a lot of guidance on COVID-19 and how we could help. The first thing is to run the HVAC longer to increase air exchange. The second thing is to increase outdoor ventilation, right? So they want to ensure that all of that fresh air is coming into that space to increase dilution. And the third thing is to open dampers to reduce or eliminate recirculation. So they don't want any potentially contaminated air to be recirculated and go back through and make it back into that occupied space. So this is what's happening right now with your space. If you have sealed ducts, which is on the left, you're bringing in the fresh air like the CDC is recommending. You're increasing that amount. You're wanting to put in a lot more dilution. And it's being mixed in with the supply air, and it's being diluted as designed, or even now it's being diluted more than designed. So you're increasing that percentage based on the CDC recommendations, and everything's making it through the way it's supposed to. But if you have leaky ducts, like on the right, that fresh air, which is blue, is going through and it's leaking out into the ceiling, into the unoccupied space. And so it's never making it into the conditioned space. And so you're not getting that dilution ratio that you want. And so that's really the main problem. Contaminated air is being recirculated. The contaminated air is lingering in that space, and the outside air is leaking into that plenum. So sealing up the duct can solve all of those problems, and you can bring in the amount of outside fresh air that you want. Now, bathroom exhaust is another issue that we're seeing a lot of problems with. This is an example of a sealed exhaust on the left. So everything's sealed up. Any potentially polluted toilet room air is being exhausted out just like it's supposed to. So any droplets or anything like that that is lingering is just being exhausted out the way it's designed. However, if you have a leaky exhaust and you think of it like a straw, if you have a straw that has holes in it and you're trying to suck out of that straw, it's not going to work, right? And it's the same with your exhaust system. If you have holes in your exhaust system or small leaks, and is trying to exhaust all that air out, it's not going to work. It's not going to exhaust the air like it's supposed to. And so all of that potentially polluted air is not going to make it out. So that causes the spread of the polluted air, and it really just stays in the space. We're not only seeing this in bathroom exhaust, we're seeing this in hospitals where they have exhaust in different areas that are supposed to take out different contaminated air, isolation rooms, things like that, where this is a huge problem. As a matter of fact, we just did a 50-room isolation room project to seal up all of those exhausts to ensure that they are isolated, or those isolation rooms are working properly. So now I'm going to turn it over to Brian, and he's going to talk more about the bipolar ionization.
Thanks, April. Hope everybody is having a good day. My name is Brian Levine. I am the Director of Marketing for Clean Air Group. We manufacture the Atmos Air line of air cleaning solutions, as well as Bioclimatic Air Systems air cleaning solutions line of product. We're based in Fairfield, Connecticut, and I think Atmos Air is a natural complement to Aeroseal. I've known Art for a couple of years now and have been following the company. I think it's tremendous technology and something that's sometimes discounted in how the built environment actually operates. I think what you're going to hear about a little bit today in terms of bipolar ionization and what we do can really naturally complement the Aeroseal process. So appreciative of the platform to present today. We manufacture a technology called bipolar ionization. We've incorporated it in roughly 120 million square feet of installed space, focusing mainly on commercial applications. It's a form of air purification. And really, for us, ArcCore Technology is based in a technology that more technically is known as dielectric barrier discharge bipolar ionization. And really, they're air ionization tubes that live in the main supply air of a mechanical system. So you can envision a discharge plenum of a rooftop unit or air handler or a main supply duct. That's where these tubes essentially live within the mechanical footprint. At the core, ion generators are the tubes. The tubes are generating millions of positively and negatively charged air ions per cubic centimeter. This is a simple thought picture of here at step 2, the tubes are in the duct generating ions. These ions live for up to 300 seconds, so nearly 5 minutes. So the goal of the system when working in conjunction with well-sealed ducts is to deliver bipolar ionization into an occupied space. The ions live for 300 seconds, transfer from the supply ducts into the occupied space where they interact with contaminants. And there's really 3 processes of air cleaning going on. We try to present a balanced quantity of positively and negatively charged ions. And these ions look to interact with suspended airborne particles, causing a process called particle agglomeration or coagulation. All suspended airborne particulate in the built environment carries a charge. Naturally, these ions look to, naturally they're attracted to oppositely charged particulate, and through this process, they make particles larger, heavier, easier to exhaust, or easier to recirculate to a return filter where they can efficiently be trapped. It's been a technology that's been used for quite a long period of time to help control odors. This ionization process, ions will surround long chain odorous molecules and break those molecules down into less complex compounds, ultimately carbon dioxide and H2O over time. So it's been a good technology to leverage to control VOCs and odors associated with VOCs. And we're seeing a tremendous amount of interest and evaluation of the technology because it plays into a virus mitigation strategy. Obviously, ventilation, air changes per hour, mechanical filtration, sealing your ducts is incredibly important. But in an effort, if a building is interested in stacking technologies to essentially increase mitigation risk, this is a great layer. And how I think it's important to understand the exact mechanism of how bipolar ionization works to quote unquote inactivate a virus. Can't say kill because it's not a bulletproof solution by any means, but inactivate is a good word for the technology. We're generating oxygen ions, and specifically O2 minus or the superoxide anion. When these oxygen ions come out into an occupied space and come into contact with a particle that's carrying a virus, when they come in contact with the protein spike or crown protein of that virus, at that specific time, they convert into a disinfectant called a hydroxyl radical. The hydroxyl has the ability to pull hydrogen away from the hemagglutinin or the crown protein and also sever the protein so that it can essentially inactivate the virus or a virus. And we'll talk a little bit about testing. We have a lot of evidence. It's somewhat discounted and not known that there's 30 peer-reviewed studies on this technology as a means to clean the air and disinfect viruses and also interact with particles by some of the leading academic journals in North America. There's also been a lot of commentary, say from Dr. Phil Tierno Jr. and other academics. Dr. Tierno is the head of immunology and former head of epidemiology at NYU Langone Medical Center, who's commented very positively on this technology as a means to control viruses. And what he's really citing in many cases is in situ or real world case studies, but also chamber environmental testing done on the products in chamber environments. So we've looked at the technology's efficacy against a surrogate of COVID-19, COVID229E. We've looked at the technology's efficacy against MS2, which many use as a surrogate of virus in general. And we have strong efficacy or reductions, in my opinion, against these viruses and contaminants and virus surrogates, both in a bioaerosolized or airborne fashion, where they look at airborne reduction rates, and also on surfaces. So again, it's that active component to the mechanical system that's going to essentially attack viruses and bacteria in an occupied space, rather than just rely on air movement, air changes, and then mechanical filtration. We've looked at, as mentioned, efficacy against coronavirus strain 229E in a chamber environment to a standardized test method, ASTM E1053 testing methodology, and putting a controlled amount of ions that would be indicative of a real-world installation, roughly 1,500 ions per cubic centimeter. Air ions can be measured in the built environment. It's one of the great benefits of this technology. And they can also be measured where they exist naturally outside. There was a 2.78 log reduction in the chamber, essentially equating to a 99.92% reduction of the virus in the chamber on a surface. And so it gives us great indication that this is a supplemental technology to help control viruses and bacteria within the built environment. This is kind of our testing, our manufacturer testing. As mentioned, there's a lot of peer-reviewed study on generally on the technology. The systems look like so. We've really engineered or built a bipolar ionization system for every size air distribution system. So most typical for a residence or for a smaller package unit are the systems that you see on the screen. The Matterhorn series on the left, which is 1 or 2 tubes, and then the fan coil or FC400 series on the right, which is a little 3-inch tube and is applicable for systems really up to 4 tons. When we engineer these systems, I try to akin it to filling up a balloon with air. We're trying to fill up the built environment with a controlled amount of positively and negatively charged ions. And what we really size or engineer to is the CFM of the air distribution, the type of space. Obviously, a wastewater treatment plant is going to be a lot different than an operating room of a hospital. So application very much matters. And then cubic feet of the space that we're serving, so we can understand square footage and ceiling heights to optimally size the system. And CFM is the main driver of selection of product. A great benefit of the bipolar ionization process in conjunction with other air cleaning measures and mechanisms is that it's easy to implement. There's negligible air pressure drop associated with the technology. As you can see, really up to 5,000 CFM. It would be an installation like this, a simple inline air cleaning strategy that doesn't impact air pressurization. It can be mounted on a main supply duct, put in a cabinet of an air handler, whether it's on the supply side or return side. Optimally, we're trying to put this system on the supply side of the air because coils, final filters, return filters can mitigate the amount of ions that essentially get into the built environment, into the occupied space. So supply side is optimal, but it's simple and there's no straight line duct mounting requirements, no configuration requirements, can be on the top or side of the duct. Relatively very easy, simple technology to engineer and implement in the building. Something that we've taken very seriously through the years. We've been manufacturing these systems now for 17 years, and bioclimatic's been around for 40 years, is safety. So we have, in our opinion, the latest and greatest safety classifications for electronic air cleaners, which is UL 2998, verified zero ozone technology. And what that really mandates or specifies is that the technology generate less than 5 parts per billion of ozone 2 inches off of the air cleaner. It's one of the standards set in place to make sure that safety is kind of paramount with an electronic air cleaner. If you were to look at ASHRAE 62.1 and some of the published permissible exposure limits, they're around 75 or 100. So this specification really is way below what we would experience kind of outside or naturally in the built environment. So in our opinion, it's very important. The other thing that we implement in commercial settings mainly is monitoring and controls. We feel we have very robust monitoring and controls that can continuously measure 8 parameters of indoor air quality. So when possible, we try to always measure particle levels, PM 2.5 size particles, VOCs, carbon dioxide, ozone, carbon monoxide, temperature, relative humidity, and formaldehyde. And we have the ability to modulate bipolar ionization output with our Atmos Smart technology. We can communicate up to 10 points to a building automation system over BACnet IP or BACnet over MSTP. And in our opinion, measurement and verification is extremely important for efficacy of the product, safety of the product, and it's nice to be able to, instead of just claiming benefit, see a measured benefit. And we've seen a lot of stakeholders implement monitoring and controls in conjunction to air treatment or just bipolar ionization. Another great way to measure the built environment is to put a device either on the wall or on a ceiling within an occupied space for more micro or granular indoor air quality measurement, and same parameters, PM 2.5 particles, VOCs, carbon dioxide, temperature, and humidity. But what we do is we try to combine those inputs or parameters into an indoor air quality index or built environment score. And a thesis that we try to present is we're trying to create healthier environments inside than what would be found locally outside. Working with filtration, ventilation, and well-sealed ducts, and really a complete system, you can measurably improve the built environment, which, as we know, has great impacts on human health. And it's nice as a building owner to be able to see this information on a computer portal, on an app, on your building automation system, and in a weekly report. Reporting and transparency is we feel a big trend that will go on probably forever as buildings become smarter and healthier. We manufacture UVC lights, but it's also important. Many people have heard of ultraviolet or UVC lights as a means to disinfect. And that's totally true, totally viable strategy and technology. Typically, UVC is working on a premise of shining a high wavelength of light on a coil for disinfection of microbial growth on a cooling coil or drain pan. Airstream disinfection is more challenging with UVC because you need more power and more run of the lights within the supply ductwork or in the air handler. We try to differentiate and say BPI is going to be active, going to look to mitigate contaminants in the space at their source, rather than rely on infectious dose of virus recirculating back to the air handler and the UVC light. It's also, the BPI strategy is a bit more dynamic in its nature in that it has impact on airborne particles and VOCs, whereas UVC is more for microbial growth and control of bacteria, viruses, and germs within the air handler. So two different solutions that are in the marketplace, both viable, just we try to present the differences so that people know there are differences. We're seeing a lot of industry commentary on the technology. It was nice to see BPI be included in the COVID-19 schools task force guidelines, in addition to MERV 13 filters and appropriate air changes per hour. They commented on looking at including UVC lights and air ionization and air handlers for disinfection. And there's been guidance to use air cleaners for which evidence and effectiveness and safety is clear. And we believe that we check those boxes with a lot of the testing that's been performed on the technology and the measurement and verification components that are offered. A great statistic, in my opinion, came from Purdue University and Dr. Yan Chen a few months back, basically saying wearing surgical masks can reduce infection risks for people by 50%. Using enhanced purification technologies such as bipolar ionization can further reduce infection risk by 20 to 30%. So not a silver bullet by any means, but an incremental layer of disinfection for buildings to evaluate. And one thing that we've really tried to pride ourselves on through the years is we've implemented it in a lot of square feet, in a lot of buildings, in many cases for some of the, in our opinion, some of the best building owners and tenants around, and some of the world's best consulting engineers. It has great application, this technology, for commercial office spaces, hospitals, schools, hotels. I thought a fun sector, or a couple fun projects to highlight over the last 12 months were some unique applications. We put this on all of Norwegian Cruise Line's fleet of boats. So roughly, we're 28 ships. In all of their air handlers, they've implemented this technology. The Empire State Building is a iconic skyscraper in New York, has also put this in their building as an active layer of control. And then we're seeing a lot of schools. I highlight the Sioux Falls School District as a school district that did 30 plus schools, everywhere from univents to air handlers. So through the years, we've been able to put together, in our opinion, a good case study portfolio with a lot of measured contaminant reductions, and also impact on energy consumption. I didn't spend too much time on that today, but there is an energy strategy around measurement of indoor air and then treating your indoor air and therefore not requiring as much dilution, which could net to less heating and cooling costs. So there is an energy impact that we present as well. But that's really for today, kind of a 20-minute overview of Atmos Air, and hopefully you guys see it as a nice complement for Aeroseal and what Aeroseal is bringing to the table. I certainly do. Thanks.
Brian, thank you very much. Boy, I learned a lot, and I'm sure that Atmos Air would be a great solution for folks that are having indoor air quality issues. As April mentioned earlier, my name is Art Wagner, and I work on inside sales for Aeroseal. For benefit of those people in the audience who haven't heard a lot of Aeroseal in the past, I thought that I would talk about who we are, what we do, and what our process is. So what is Aeroseal? Well, it's a proven patented technology that seals HVAC ducts from the inside out. This technology was developed at the University of California, Berkeley Labs, about 20 years ago with Department of Energy funding. And our goal really was to come up with a way to seal ducts and not be as invasive as other measures might be. Ductwork is pressurized, and then we inject an aerosolized sealant into the ducts that reduces 90% of the leakage. I really like it because it eliminates any kind of human inconsistency. We don't have any kind of access limitations. I mean, picture if you put in a new project and you find out that you can't meet code, rather than rip down sheetrock in insulation, Aeroseal would be a great application because our product will find holes in the system without the need of human eyes. The results are also tracked in real time. You can see the picture on the right of one of our technicians that uses a computer to find out exactly where we are in the sealing process, and we'll be able to provide a report for each area that's sealed, floor that's sealed, or building in general. The payback usually is only 2 to 7 years because of the leakage that April had mentioned early on. That could be so severe, and Aeroseal will be able to take between 85 and 90% of the available leakage and get it closed off. As I mentioned, all of our work is verified with a certificate of completion, and the work itself is guaranteed. April, if you could advance the slide, please. Thank you. When we apply Aeroseal, I get a couple common questions. First off, does our product coat the inside of ductwork? Well, the answer is no. It will only go to where the lowest pressure points are, which would be indicative of a leak. It only sticks to the holes, and it can span holes up to 5/8 of an inch in diameter, or a seam that is 5/8 of an inch wide, and its efficacy is guaranteed. You can see on the video on the right, it's kind of an exciting quick time-lapse photo of a hole in the duct that we created and put a mesh over that hole, and then watched how the Aeroseal particles can bond to each other and form a complete seal. So you'll see it as being black early on, right? That's when you can see right through the screen. And as the process begins, the compound itself, which is white, starts to form and coagulate on itself. Often I'll get a call in the office saying, hey, I'm interested in your product, but I'm not quite sure that my building is a good fit. So we come up with a list that we typically share with potential customers to say, hey, this is what we think would be a good fit for you. First off, the return on investment is typically better for large buildings, greater than 8,000 square feet. I know that we use an analogy that says if you can throw a baseball over the building, it might be a little bit small for us to consider and have a positive economic payback. We also look for buildings that have high occupancy and high outside air needs. Those with high static pressure and older buildings also are really going to be good candidates because the ductwork may not be in as good a shape as newer buildings are. And as April mentioned earlier, from an exhaust standpoint, we also tend to focus on those buildings that have dedicated exhausts, like dorms, labs, or multifamily. So let's say you're interested. Folks will say, what's the next step in the process? We will have plans and drawings made available typically. Once we've had a chance to look those over and get a good feel for the system on paper, we'll send out a couple of our service technicians and managers to do an on-site audit and evaluation. It really is just kind of an eye check on some of the areas that you think you might be having trouble with, and it gives us an idea of what might be waiting for us when we're given the approval to go ahead with a job. We'll do testing and planning at that point in time. If we think that the building is a good candidate to move forward, we would want to do any kind of repairs, cleaning, sanitizing, and sealing before we aerosealed. I get asked questions pretty regularly, if ducts are dirty, can we aeroseal over that? Well, we recommend that if you have 1/8 of an inch of debris on average throughout the duct system, that we clean that first and then aeroseal. Once the process is started, we'll do our initial measurement and verification. We'll talk about that a little bit later. So during our on-site audit, we're going to look for a couple things specifically, and you can see the picture on the right is a good example of damage that ductwork has had to face. We'll look for signs of any kind of mastic or manual sealing, metal tape, because obviously it's going to tell us that there's been an issue in a specific area before. We'll also take note of duct type. We can see any of the duct types located on this slide. We wanted to make sure that when we put together an estimate, we know what we're working with. We'll also measure static pressure and identify VAV and access door locations. That will help us put any kind of blocks into the system that we might need to guarantee the pressurization in the area we're treating is correct. Also, it'll help protect some sensitive areas like VAVs, so we don't have to necessarily seal through them. We'll look at connection types and also a couple telltale signs that we'll look for that Aeroseal would be a good fit is inflated insulation, any kind of damaged connections as you see up above, any pencil trace marks that you could see dirt-wise that would indicate leakage, and any canvas connectors. We'll also look at those because they tend to deteriorate. Once we've done our pre-audit evaluation, we typically ask for a few points of information back from the customer as well. And this helps us put together an energy model for those of you who are interested in energy savings, and it helps us compute what the payback will be. So we'll look for occupancy hours, energy costs, and that includes any kind of demand charge that you might have, summer and winter design conditions, as well as your location. From the drawings and mechanical schedule that we'll receive in advance of doing work, we're going to be able to look at the fan design and flow, what the external static pressure is, look at efficiency numbers, as well as the outside air percentage. And if you've had a tab report done, we'd also want to look over that to help determine duct leakage at the start of the project compared to what the end result would be. And the last slide that I have to share is what we provide from a measurement and verification standpoint. So what really makes duct sealing a viable ECM? First off, it's measurable and quantifiable. As I told you earlier, we have the ability to track and control sections that we're going to be sealing and show you just how well we've gone ahead and sealed it. What you can see to the right is a certificate of completion, typically done per area or by floor. The pertinent information there will show how much square footage of leakage you had, what the CFM leakage is after we did the sealing, and then what the percentage of reduction is. In this case, we were doing some work in Ohio and found out that the before and after, we were able to save 95% in reduction of duct leakage. So it's something that's verifiable. I think it's an exciting program to be able to look at. I'd also tell people that this is not a product that needs to be reapplied. Once it's applied, and if the ductwork is left alone, there isn't anything that you're going to need to do. And as we say, we have a laboratory certified 40+ year lifespan on the product. So I'm excited about Aeroseal. I'm also excited about Brian and the product that he brings to the market. We thought it would be beneficial to kind of show two technologies at the same and how might they be mutually beneficial to each other. I know we have a little bit of time left, April. If you want to take a couple questions, I'd be happy to answer them.
That's great. I think Billy was going to pull the questions for us.
Yes. So you mentioned BAC net protocol. What about LON works? Brian, is this one something for you?
Yeah, it sounds like it's a communication protocol for the Atmos Smart and Atmos Aware sensors that measure the built environment, measure the air quality. Right now, the functionality is with BACnet, IP, MSTP, and for the Atmos Aware products, also Modbus. I don't have a lot of experience right now with LonWorks. So those would be the communication protocols as of today. There is potential for others, but I don't want to overspeak or overcommit.
Fair enough. Another one here for Atmos. How do you respond to the question of potential long-term health effects caused by ion exposure?
Definitely. Well, one I always fall back on to, we've all breathed in ionized air, or we're breathing in ionized air right now. It's an interesting thought picture to switch to. If you go outside, typically near beaches, near waterfalls, in more natural settings, you're looking at between 1,000 and 5,000 ions per cubic centimeter. So if you remember, we're looking to achieve between 500 and 1,500 ions per cubic centimeter in the built environment. So it's a controlled amount of ionization is the first part of response. The second part of the response is a little bit more technical and detailed, but there's now been two published and peer-reviewed studies in academia on this exact topic: air ions and respiratory health, air ions and human health, and air ions looking at animals as well. So in the two studies that I'm mentioning, there was no harmful human effects measured whatsoever. In the study with animals, they looked at this process over the course of 5 years and saw no memory, no influence to humans. Now, it's interesting too to think about the complex viruses, bacteria, and then human cells. Dr. Tierno talks a lot about eukaryotic and prokaryotic bacteria and how ions will essentially interact with each. So there's a lot of, I think there's a detailed answer to that question, but there is now some peer-reviewed studies on that exact question showing negligible, no ill effects at a controlled ionization rate, which is what we look to achieve. Hopefully that's somewhat helpful.
What are the warranties on both products? So Brian, do you want to go first?
Sure. Yeah, the warranty on an Atmos Air system as of today is 2 years. Optimally, the tube should be replaced every 2 years. We have systems in the field that are 15 years old, so there's systems out there that have been out there for a while.
Yeah, so on the Aeroseal side, our longevity studies shows that Aeroseal lasts for over 30 years. Our current commercial warranty is 3 years. And if we are actually doing some testing in some of the earliest Aeroseal commercial buildings this summer with Dr. Mark Madera at the Lawrence Berkeley Labs. And so we'll be able to show even past lab studies that Aeroseal has held up in some of those early buildings. So we're excited to get that published and out for everyone. But yeah, so our Aeroseal warranty is 3 years on commercial projects, and but our longevities show that it lasts for over 30 years.
Brian, I got another one for you. Might there be any building applications where BPI is already known not to be compatible?
Yeah, I think that's a great question. I think in the theme of this presentation, if your ducts weren't well sealed, if you're not getting good air distribution, the system is not going to be that effective. Ions are like, somebody said it to me the other day, and it's stuck, I guess. They're like hitchhikers. They're along for the ride with the airflow. So if you have null pockets or dead corners, or you're not getting air movement to specific areas, we all know about, or many of us know about design CFM, what the building was laid out for versus actual. And I think that speaks a lot to leaky ducts. If you're not getting the air movement to those areas, the ions aren't going to get there, and therefore the disinfection won't really be occurring in the built environment the way it's intended to. So that would be one interesting point of reality. And then there's some applications that take a lot of human touch. We're doing a project right now for NASA in Houston, and it's all about treatment of specific fixed gases and odors. So if we were to just design a basic rule of thumb system and just say, hey, the CFM is X, we would probably come up short and not be able to really help them with their issues. So I guess I would turn the question to, there's a lot of custom engineering that sometimes goes into a successful installation and system.
Okay. What does the installation process look like? Is this done by subcontractors or in-house?
For Aeroseal or for Atmos?
It doesn't have a actual who's it guided towards, so I'll just open up to both.
Mm-hmm. Well, I can say from an Aeroseal standpoint, Billy, that we have a number of approved dealers, both from the residential and commercial side, that serve Aeroseal, that have been trained to apply the product. In areas of the country where we don't have application coverage, we'll be able to take care of that from a factory direct standpoint. So any customer in the United States or across the world, for that matter, will have coverage either via dealer or through factory direct.
From the Atmos Air side of things, we have a dealer network as well, and really serving all 50 states, and a lot of, we have a nice presence internationally as well. But we work with mechanical contractors every day, specifically on plan and spec construction projects, different groups that haven't necessarily installed our technology. It's relatively simple. In many cases, just for the BPI, it's either mounting it to a plenum or cutting a hole in a duct and mounting it to a main supply duct. So it's pretty easy. And then there's an electrical component of bringing power to it. The power consumption is not great, less than 50 watts for all of our units, less than 0.6 amps of draw for all of our units. But we work with a lot of different contractors, and there's a lot of different ways, I guess, to execute an installation.
For the Aeroseal crew, how many systems would be required for a larger building? A lot of pressures, lots of it's a long statement here. Essentially, there's a lot of pressures I'm gathering from this. That is one system adequate for a large building?
Yeah, so what we would do in a system like that is we would bring multiple fans or fan boxes to ensure that we can get pressurization in the section of duct that we would be sealing. And we would probably do that in different sections and do multiple injections. So we do large duct work all the time. We do incredibly large sections of duct. But just the most important thing for us is that we can hold pressure so that the sealant makes its way through the duct. And so in order to do that, sometimes we need multiple fan boxes, things like that. So our engineering team would take a look and decide the best course of action, but we're always able to find a solution and figure out the best way to do a project like that.
Perfect. I think that was the last one I have to right now. So I will pass it back over for closing statements. And if anybody else has any questions out there on the line, feel free to put them in. And time permitting, as we get close to the end of the hour, you might be able to grab them. Brian, would you like to share any last thoughts, any last alibis?
No, just appreciative of the opportunity. Thank you, Art, April, and Billy for putting this together. I think, like I've mentioned a couple times, I think it's a natural complement to the technologies, and we really respect everything that you guys are doing. We're all working together to create healthier, more efficient buildings, reduce the carbon footprint. So thanks again for the opportunity today.
Yeah, and we just want to thank Brian for joining us on the webinar today. And just to reiterate Brian's point, if your system is not working properly and your air is not circulating, you're not going to make it through to the ionization systems. You're not going to make it through the filters to clean them at all. So it's very important that you address duct leakage and other issues, just so that systems like Brian's and Atmos Air get a chance to do their job, and that, you know, we make buildings healthier for everyone going back to work. So we're really excited here at Aeroseal to be able to come back to the office in a safe building, and we're here to help you do that for all of your building occupants and your customers. So we're here to help. Our information is at the bottom of the screen. If you have an energy savings project or an ESCO customer, reach out to me and we'll send out my information to everyone that was on the webinar as well. And the process is a little bit different for you, but we're here to help support in those projects as well. So thank you all for joining the call.
Yes, thank you.
Great. Well, I don't have any other additional questions that have come in, so I will let everybody get back to their day and appreciate everybody for joining us. Thank you.